Welcome to a discussion on state machines. Today, we're diving into the world of digital logic and designed to explore and differentiate between Mealy and Moore state machines. Get ready to understand these fundamental concepts. So, what exactly are state machines? They are mathematical models used to describe systems that operate through a series of discrete states, transitioning from one state to another based on certain conditions. State machines are essential in various fields, including the design of digital circuits, software engineering, and the development of control systems, providing a structured way to manage complexity. State machines are broadly classified into two main types: Mealy machines and Moore machines. The key difference lies in how they determine their outputs. In a Mealy machine, the output depends on both the current state of the machine and the current input it receives. In contrast, a Moore machine's output depends solely on its current state. Let's take a closer look at the Mealy machine. One of its defining characteristics is that the output changes immediately in response to the input. This makes Mealy machines very responsive to changes in input, resulting in faster processing times. Mathematically, the output of a Mealy machine can be defined as a function of both the current state and the input, represented as output equals function of current state and input. Now let's explore the Moore machine. Unlike the Mealy machine, the output of a Moore machine changes only when the machine transitions from one state to another. This results in a more stable and predictable behavior. The output is not directly affected by the input. The output of a Moore machine is solely a function of its current state, which can be expressed mathematically as output equals function of current state. Let's summarize the key differences between Mealy and Moore machines in a comparative way. The main aspect to consider is output dependency. Mealy machines produce output that depends on both the current state and the input, whereas Moore machines generate output based only on the current state. Another key difference is in response time. Mealy machines offer an immediate response, changing their output as soon as the input changes. Moore machines have a one-clock delay, updating their output only when the state changes during a clock cycle. To illustrate how state machines work in practice, let us consider a simple example: a traffic light controller. This system manages the traffic lights at an intersection using state transitions triggered by sensors and timing mechanisms. The traffic light cycles through a sequence of states: red, green, yellow, and then back to red, based on predetermined conditions. Finally, let's address the question of when to use each type of state machine. Choose a Mealy machine when you need an immediate response to input changes and require faster processing. This type of machine is ideal for applications where timely reactions are critical. On the other hand, opt for a Moore machine when you need stable outputs and synchronous operation aligned with the clock signal. Moore machines are well suited for systems where predictability and synchronization are paramount. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.